Everyone, so today we will be solving Leetcode 874 Walking Robot Simulation. In this question, we are given a robot on an infinite xy plane and it starts at point 0, 0 facing north. So we have to give commands to it. So there are three type of commands: -2, which is turning left; -1, which is turning right; and k, which ranges from 1 to 9, which is move forward k units, 1 unit at a time, in the direction in which we are currently. So we would also be given a list of obstacles. If the robot runs into an obstacle, then it will instead stay in the current location and move to the next command. So we have to return the maximum Euclidean distance that the robot ever gets from the origin, and we have to return the square of it. So it means that if the distance is 5, we return 25. Yeah, so let us take this example number 2, and see how do we go about this problem. So yeah, let us take the example. Yeah, so initially we are facing north at point 0, 0. So we are facing north 0, 0, right? Yeah, so we have to move 4 units to the 4 units in the direction in which we are facing. So we are currently facing north, so we move 4 units to the north. Okay, we move 4 units to the north. Now -1 is turning right 90 degrees. So currently we are facing north. Now if we turn right 90 degrees, we would be facing east direction, right? And we have to change our direction now. So our direction is east. So the next command says, let us change the direction to east. Yes. Yeah, so we have changed our direction to east. Yeah, so the next command says that we have to move 4 in the direction in which we are facing. So right now we are facing in direction east, so we have to move 4 units to it. But we have an obstacle at 2, 4. So the question says, if we have an obstacle, we have to stop at the point before it. So since here is the obstacle, so we have to stop at this point. At this point we have to stop. We can't move more than this point, right? Yeah, because we have obstacle here. So we now it says -2 is turning left 90 degrees. So right now we are facing east. If we turn left 90 degrees, then we would be facing north again. So let us turn north. Yeah, so now from here we are facing north, and we have to move how much? 4 units, right? So 4 units, 1, 2, 3, 4. Yeah, so we move 4 units to the north. So at which point do we land? We land at 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we landed at 1, 8. So here is, we landed at 1, 8. So we have to return the maximum distance from the origin at any point of time. So we were at origin 0, 0, and we landed at 8. So the distance would be square root of how much? 8. 1 minus 0 squared, which is 1, plus 8 minus 0 squared, which is 64. And the question says that we have to return the square of it. So if we return the square of it, then we get 1 plus 64, which is how much? 65. So our answer is 65. So we have understood this. Now the second point is, how do we know, how do we change the coordinates in when we get -1 and -2? So let us see. So for example, if we are so for example, let us draw. Yeah, so for example, let us take that we are facing in this direction. This is east direction, and in east direction what we do, we have to increase by 0, 1 every time, because we are not moving in we have to increase by 1 comma 0 every time, right? Because we are moving in x direction and not moving in y direction. This is our north, and when we go up, then our x coordinate remains same, but we increase our y coordinate. When we go south, what we do, we make the x same and we decrease our y coordinate. And when we go west, um, and when we go west, what we do, we decrease in x and make the y as same. Okay, so let us assume, let me take a different color. Yeah, so let us assume that we were facing east initially. Now we get -1. -1 says that we have to turn right 90 degrees, so we have to turn in this direction. So if you carefully observe what we did, uh, when we turned left, our initial y coordinate became our x coordinate, right? And our initial x coordinate had changed to negative of the new y coordinate. Yeah, so if initially I was at x comma y, right, then if I turn left, then where would I be? I would be at y comma minus x. Okay, so now let us take another example of turning right. So for example, let us assume that we were facing west and we have to turn right to move to north. If we turn right, we'll move to north. If we turn right, if we turn right, we move to north. If we turn left, we have to we'll move to south. So we'll be checking the right part first. So if initially we were at x comma y, on going right, what happens is x comma y. So on going right, what happens is our initial x coordinate becomes the x coordinate unchanged, so it's x, and y coordinate gets -1, right? Yeah, so basically initially it was -1 here. Here when we come, it becomes 1, because we have to take minus of -1, which is 1, and x is similar, right? So we have x here and it will be x, we have x here and it will be same as y coordinate here. So yeah, so this is how we'll be changing the direction, and we would be simply simulating it one step at a time. So let us go about coding it. Yeah, so let us take initial direction in pair of int comma int direction. This will give me the initial direction, which would be 0 comma 1, because it is north. We are facing north initially. Yeah, the robot starts at 0 comma 0 facing north, right? And our initial x coordinate is also 0 and initial y coordinate is also 0. So we have to also make sure that we don't run into obstacles. So let us store obstacles in a set, in an unordered set. So unordered set of string s. So for int I equals to 0, I less than obstacles dot size I plus plus, what we have to do, so s dot insert what, to string obstacles I comma 0 plus, let us take a delimiter, plus 2 string of obstacles I1. So we have simply stored our obstacles in an unordered set, so that we know if a given x comma y is an obstacle or not. So for int I equals to 0, I less than commands dot size I plus plus. Okay, so in command would be commands I. So we have three choices. If command equals -1, what we have to do is turn left. So our direction changes. So our new direction would be initial direction, which was direction dot second comma direction dot first, and which one has -1? Let us see. We are moving left. So we are moving left, so this goes here, and y coordinate will have a negative 1. So -1 into this, else if command equals to -2, then, and we just continue here as well, then our new direction becomes what? Direction dot second, but this time this coordinate will take -1, comma initial direction dot first, and we just simply continue. Else we have a third case, while command minus minus, what we do is so this is the third case in which command could be from k equals to 1 to k equals to 9. So while command so our new x becomes x plus direction dot first, our int new y becomes y plus direction dot second. So we have to see if it is an obstacle or not. So if as the find to string new x plus dot as a delimiter plus to string new y is equals to s dot n, that is, we do not have an obstacle here, then simply our x becomes our new x and y becomes our new y. Okay, otherwise we break because we found an obstacle and we can't move forward, and we have to wait for the next command, right? And what do we have to return? The maximum Euclidean distance, right? So let us also take that. So in maxi would initially be 0, so else, otherwise here we update maxi to maximum of maxi comma x into x plus y into y, right? Otherwise, if we are able to update, so maxi is equals to maximum of maxi comma x into x plus y into y. Yeah, so we have to return maxi. Let us run. Okay, there is an extra. To underscore string s dot find. Yeah, it is passing all the test cases here, so let us submit. Yeah, it's accepted solution. Thank you.